All right, and welcome back. So today we are going to be starting our conversation about different sequences that we can analyze within algebra. The first type of sequence that we are going to be talking about is what we're doing today. It's called an arithmetic sequence. And there also is another type of sequence, but we'll get to that later. But today we're going to be talking about arithmetic sequences and how we determine if they are or are not an arithmetic sequence, what they actually are, and how we can deduce an equation to help us find specific values. So without further ado, let's begin. So an arithmetic sequence, all it is, it's a list of numbers, or we call them terms, that have a common difference between each number. So either we're adding the same number or subtracting the same number. And after we can find that common difference, the number we're adding or subtracting, we can use it to continue the sequence. So all this really is analyzing a pattern. Can we find a pattern within these terms to then say what the next few terms are going to be? So for example, let's go through one that is not going to be an arithmetic sequence. So the first question that we're going to be doing is we're going to try to determine whether each sequence, is an arithmetic sequence. If so, we want to find the common difference and the next three terms. And again, the common difference is the number that we add or subtract each time, and that stays consistent. So if we have the numbers 1, 2, 4, 8, so on and so forth, we want to find out how much we're going to add or subtract as we move from term to term. Well, as we go from 1 to 2, we added 1. From 2 to 4, we added 2. From 4 to 8, we added 4. What do you notice about those differences? Are they the same? Are they common? Are they constant? No, they're not. From the first to the second term, we're adding 1. The second to the third term, we're adding 2. The third to the fourth term, we're adding 4. So we're not adding or subtracting a common value. So with that, this is not going to be an arithmetic sequence. So since we're not adding or subtracting by the same value each time within this pattern, this is not going to be an arithmetic sequence. But let's look at another example. Let's say we have the terms 0, 6, 12, 18. We want to figure out the common difference between those numbers. Well, each time we're going to be adding 6. So this would be an arithmetic sequence because the difference is constant. We're adding 6 every single time. So again, we would say this is an arithmetic sequence. The common difference is going to be 6. Positive 6 because we're adding 6. If we were subtracting a value, it'd be negative of it. But since we're adding 6 and we're growing by 6 every single time, it's going to be positive 6. And we can use that difference to find the next three values. So just like you would in an everyday scenario, without knowing about this specific arithmetic sequence, you would just add 6 each time. So 18 plus 6 is 24, 24 plus 6 is 30, 30 plus 6 is 36. So those would be your next three terms. Great job, folks. Please work on problems 1 through 6 on the guided note sheet and resume when you are ready to move on. All right, if you're listening to my voice, that means you have completed 1 through 6 on the guided note sheet and you are ready to move on. So sometimes it makes it easy for us to deduce some kind of equation or some formula that's going to allow us to find some number term. In the previous example, we asked you to find the next three terms. Well, there are going to be certain times where we want to find the 60th term or the 112th term. And it would take a very, very long time in order for us to write out all of those numbers. So we have this handy dandy formula. It's a sub n is equal to a sub 1 plus, in parentheses, n minus 1 times d. And that's a lot there. So we're going to break it down. So a sub n means it's whatever term we are trying to find. If we are trying to find the 10th term, well, it'll be a sub 10 because n stands for the number term we're trying to find. A sub 1 means a subscript 1, I just say sub 1, is going to be the first term in our sequence. n is the term number that we are trying to find. So if we were trying to find the 10th term, well, that n would be replaced with 10. We're subtracting 1 because we're already accounting for the first term. So if we're trying to find the 10th term, well, we already have the first term listed, so we want this overall value in the parenthesis to be 9 because we have 1 term plus 9 terms. And your common difference is going to be represented with D. So we can write this rule and you help us to find any term that's going to be within the sequence. So let's go through an example. Let's try to find the 50th term of this given arithmetic sequence. We're given 5, 3.8, 2.6, 1.4. The first thing that I notice is that the first term is going to be 5, and I'm getting smaller each time, which means we're going to be subtracting. Well, we're subtracting by 1.2. So that means the common difference is going to be negative 1.2. Again, when we're getting bigger, we're adding, it's a positive difference. When we're getting smaller, we're subtracting, so it's a negative difference. So D would be replaced with negative 1.2. So we're going to first write out the rule, which is, again, the general form of it. It's a sub n representing the number term we're trying to find, is equal to a sub 1, that first term, plus n minus 1, n being the number term we're trying to find, take away 1, times that common difference. We know that 5 is going to be the first term. That gets filled in for a sub 1. We then have n minus 1 times the difference. Our difference is negative 1.2. We now know we were trying to find the 50th term, so we're going to replace n with 50. And notice how we replaced it twice. The first was a sub n, it's now a sub 50. So we're trying to find the 50th term. So that visually tells us, hey, the 50th term is going to be equal to da 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 da. Now we also replace n with 50, and we simplify. 50 minus 1 is 49. We then multiply by negative 1.2. We add 5. So we get the 50th term, a sub 50, is equal to negative 53.8. Therefore, that is going to be our final answer. The 50th term is equal to negative 53.8. And that would have taken a very, very long time for us if we had to handwrite that out and try to list with that pattern. So you've grown up finding and deducing patterns and recognizing these mathematical patterns without you even realizing it. And all we're doing now is taking it and formalizing it and saying, hey, if we want to find X number of terms, well, this is how we are going to do it. You will need to know this formula. It is going to be very important for us moving forward with arithmetic sequences. And there is another sequence that we will talk about later. But great job today with arithmetic sequences, which again, we're adding or subtracting by a common difference. We want to figure out what that common difference is. If it's increasing, we're adding, it's a positive difference. If we're decreasing and subtracting, it's a negative difference. And then we have our handy dandy formula, a sub n, meaning the value of the nth term is equal to their first term, a sub 1, plus the number of terms minus 1, because we're already accounting for that first term as our starting point. And then we multiply that by the common difference because we're increasing or decreasing from that first term by this amount of value. Great job, folks. With that in mind, please work on problems 7, 8, 9, 10, and 11 on the guide note sheet. Please jot down any questions that you have, and have a great day.